Hello, everybody. This is Diane Mueller. I'm the co-chair of the Operator Framework SIG, and we are going to give everybody a few more minutes to join us. In the link to the HackerMD notes that I'm taking, you do have to sign into HackerMD, but if you can add your name to the attendees, that would be great, and your affiliation. In fact, there'll be a lot of Red Hatters on here because it's a hot topic internally and with Red Hat and with our customers. So sort of the nature of the beast right now. And we'll give everybody a few more minutes and we'll start a little bit after the hour. I'm still just 9 o'clock my time on Pacific time. And so I'm waiting for my other co-chair, Rob Szumski. Szumski, I think that's how you say it, Szumski. I'm always putting an AN in there. And let's see. Yeah. Hey, Leonardo. Thanks for joining. On the agenda, Leonardo. So we'll kind of motor through this. I'm kind of just waiting on my cohort here, Rob Szumski, to join. And Rob gets here. We got a good crowd of people today, which is always.
Hey, Diane, I don't know if anyone else is experiencing this, but your voice is going in and out right now.
Okay.
Happened a little bit for me.
Stop video. How's that? Is that a little bit better, Peter?
Sounds much better right now, yes.
Okay. Well, you're not going to get to see my shining face today, so folks, just suffice to say it's snowing.
So disappointed.
I know. It's snowing in the background here, so there. And Zach's joined us. Good. I'm just waiting for another minute or two. Otherwise, I'm just going to pop on and get started here. Today we have a couple of people that are new to the community that have just been popping onto my radar that I've asked to come and sort of introduce themselves. And the order on the agenda is really flexible. And we'll wait and see for a minute or two if Rob manages to join us. I know he's been crazy busy.
I'm here.
You're here. Okay, great. So let me just share my screen for a minute and we'll get ourselves started here. Perfect. Boom. So Rob and I, we get the wonderful chore of, and it's not a chore, of chairing this SIG. And it's really basically a place for us to share the stories and best practices and the lessons learned that everybody's created or learned during their endeavors to build operators or to work on the operator framework itself and OLM and metering and the SDK. And Rob is here, and I'm hoping that what we could do to kick this off, Rob has been diligently working on some documentation, and I was hoping I could get him to talk a little bit this morning first to kick it off on this topic of how to add your operator to the operator framework repo, and maybe give us an update on that. So, Rob, if you'd like to take the screen and share, that would be wonderful. And I'll stop sharing and take notes.
Alrighty. All right. So I wanted to talk through how to add operators to some of our community repo here, which I'm looking at. But I wanted to first kind of talk about, so we have this awesome operators repo, and some of you, I think, or probably many of you have added your operators to this list. What this kind of represents is just kind of like a collection of operators that exist out there with no information kind of about their quality, which versions of Kubernetes they work with, how to get them installed, other than, hopefully there's a README going on. And so this kind of, if you think about this and contrast it with what it would look like to install a binary from somebody's Git project, it's kind of like you're running make and to get a binary and you have it locally on your machine, really not great for like actually sharing these out. So what we want to do is kind of to further that analogy is have the operator version of RPMs, or actually packaging this stuff out, versioning it strongly. And so that is what we have a new effort under this community operators repo. This is a set of manifests of operators that have been bundled up to work with our operator lifecycle manager. And this really means that you have a better experience for shipping these operators. If you do get a new version of an operator, the cluster knows how to upgrade that with a rolling deployment to the new version, so that as folks are putting out bug fixes, new releases, that you have a stable, sane way of getting that, just like you would do with an RPM today on one of your servers. So documented in this repo is a set of early steps to accomplish this. And what it really comes down to is following this guide right here to make a cluster service version file for your operator. This doc is available on GitHub. You can go read it. I'm not going to read through the entire thing, but what it does is have a bunch of metadata about your operator, just the versions, how it wants to be installed, some of the CRDs that you own. And this section in particular is actually really important. So instead of it being the Wild West on a cluster, these CRDs are cluster-wide. And so you need to make sure that different operators are not owning different CRDs, especially their instances inside of your namespaces. And so what the lifecycle manager does is go kind of deconflict all of these CRs and CRDs that exist on the cluster, such that they're only owned by one operator at a time. And so this is how then you can start having operators that work with each other through these CRD interfaces. Another section of this guide is about not CRDs that you own, but CRDs that you depend on. And so these are the required CRDs. So if you have a database operator that wants to cooperate with the Prometheus operator, for example, to set up service monitors to monitor the database that you're running, you can start expressing all of that inside of this file. Other things that are in here are just a bunch of other things about the APIs that you require, and then some metadata about minimum versions of Kubernetes that you work on, for example, this min-kube version here, the maturity level of your operator so that you can kind of signal that out to folks, and then, icons and that kind of stuff. What we want to do as a community is then have a list of all of these that are tested and known to work well. So inside of this community repo, we want to run some automation against your operators so that we know that they work against, an upstream conformant kube cluster, for example, and those types of things, and also to power some over-the-air upgrades, that smooth process of actually obtaining a new version of an operator, then applying that to your cluster. And so we've got some more information about testing that process. And so that's kind of the main part of it, is to make sure that we have a consistent way of running all these operators such that folks can take down your operator, install it on an OpenShift cluster, an Amazon, a Microsoft, an upstream cluster that you booted with kubeadm, a COPS cluster, whatever it is. We want to make sure that everybody has a really great experience there. So I'll drop some of these links into the doc, but this is available on the Operator Framework GitHub page under the Community Operators section. So would love to take any questions if anybody has them now, and also help folks with this process. We've got a number of folks that are experts in how to do this and some of the benefits of it. And so we can do that over Slack or whatever mechanism folks are interested in.
Good. Does anyone have any questions, comments for Rob? You can always reach out on the Google group and ask questions as well. People are always lingering around there, or in the Kubernetes operator Slack channel on Kubernetes too. So there's lots of places to get help and get questions answered about this.
Actually, there's one more thing I wanted to cover, which is just kind of interesting, is doing this for your operator kind of forces you to think through some architecture, which is pretty interesting. And one of those is this install modes. So if you built an operator on the call, you know that you have some different mechanisms for what events you're listening to. You're either looking at cluster-wide events, you might be looking at just a very specific namespace. And so what you can do is actually tell other users of your operator how it understands to listen for those events. So you can run in your own namespace, so basically saying this operator needs to run and watch the same namespace. This operator only knows how to listen to a single namespace, but it can run, in a different namespace from that. I understand how to watch multiple namespaces. This is if you had an operator that you want to watch, a number of production namespaces, and you can list those out in a comma-separated values. And then I watch all namespaces. So it's a bunch of interesting kind of architecture decisions that this is making you think through. And so I think that's just kind of an interesting bonus of doing this, is you can start thinking about how you want to best run your operator, what makes sense. Is it a namespace, all namespaces, for example? I want to provide a cluster level service like storage to the entire cluster. Or is this a very specific operator where you want to run a bunch of them, and so maybe I want to listen on a single namespace, that type of thing. That's all.
Any questions? All right, pop back. And I wanted to ask, we have a sort of a new community member who's not really a new person at all, James Cammarata, who's one of the leads around on Ansible and Ansible architects, and he is busy moving into his new apartment or house or something like that today, and he's taken a few minutes, and he's been working on Ansible and operators and has around Galileo. But I'll let James, I was just going to have you introduce yourself and talk a little bit about the work that you're doing right now.
Sure. So like Diane said, I've been the Ansible BDFL. For if people don't know what BDFL is I'm kind of like the Linus of the Ansible project. Since about 2015, after Michael, the original creator, left the company. So last year I started getting asked to kind of help out with some OpenShift Kubernetes things, and specifically the Ansible operator project. I don't know how many people are familiar with it, played with it, if not, but basically it lets you bundle up an operator that uses Ansible playbooks instead of having to write Go code or some other kind of language-specific code. So it really lets you create operators much more easily. To highlight this, last August we got together and met up and started kind of working on some things. A few people started working on converting some of the Go operators to Ansible operators, specifically the HashiCorp Vault and the etcd operators, just as kind of proof of concept to show how easily it would be to do those Go-based operators as Ansible playbooks instead. It ended up being pretty easy. So we started kicking around ideas about other things to tackle. And I love OpenShift, not just as a Red Hatter. I used OpenShift very early on in the 2.0 series before it was completely rewritten to be Kubernetes. So as a side project, it always kind of my side projects, it annoyed me that I couldn't scale up my MySQL databases that easily inside there. If I click the up arrow on the pods for MySQL, all I ended up getting was two separate MySQL instances running that didn't talk to each other. It was kind of not very useful. So I thought doing some of the more complex database stuff in operators with Ansible would be a really cool way of showing that, how easily it would be to write some of these operators in Ansible. So Galera was the first one I tackled because, MySQL, a lot of places use it. And with Galera, it's really easy to scale up. If you haven't seen it, it's very similar to like Mongo. You basically just spin up another one and tell it where the cluster is, and it handles it all, and it's all multi-master. There's no, master tier versus, read-only slave tiers, things like that. You can still do that with MySQL, but with Galera, it's much easier. So I started working on a blog post showing how easily it is to, create this Ansible operator to manage your Galera cluster, scale it up. The blog post covers, spinning up OpenShift and AWS, create the cluster and then deploy the MySQL, the Galera operator on it, and then start doing some load tests against it using Sysbench. And just shows that, when you scale up the number of pods that your CRD defines, that, you start getting this really nice linear scaling of, SQL throughput using Sysbench. So that should be going live probably in the next month. Again, as Diane said, we just moved, and with the holidays and everything else, it's been kind of hard getting the finishing touches on that blog post, but hopefully in the next month we'll get that up and out. So any questions? Anything about the blog, anything about the Ansible operator in general?
So I have a quick one for you. The Galera Ansible operator that you're creating, is it just an experimental thing, or is it something that you're going to maintain over time?
I don't know if, sorry, go ahead.
Or is it going to get moved into the Galera repo itself, and maybe some of the Galera people will take advantage of it and maintain it for you?
Yeah, the ultimate goal would be, this was kind of a proof of concept, so I was just writing and maintaining it, so it definitely doesn't handle all failure scenarios properly right now. It's, it starts up, scales down, does persistent storage, things like that, but as far as some of the more mature ones that are written in Go, it doesn't do things like backups, and if you totally kill the cluster, it may not start up right, depending on how you kill it. If you go in there and kill pods directly, or like your cluster, your entire K8s cluster or OpenShift cluster gets wiped out, it may not restart exactly the way you think it would. So ultimately I would love it if somebody took it over. We want to move it into the operator SDK examples repository. Right now it's still in what that link that is on the HackerMD is what we called our waterhole. It was kind of our work in progress repo for stuff we were doing with Ansible operator. Let's see. APBs are not really supported in the Ansible operator. The APBs was kind of a separate thing. I likened them more to basically it was more along the lines of what an RPM would do to basically get something installed, and not really the second day tasks. With the operator, it's much more flexible. Oh, Michael responded to it as well. So, any other questions?
Okay. There's like a little bit of back and forth. I'm going to unmute a few people here so that maybe they can chime in. Maybe Leonardo, you're self-muted, and
so to answer your question, Leonardo, yes, you basically write the playbooks, and then using the operator SDK command line, you bundle that up into an operator that you then launch on your K8s cluster or OpenShift cluster. And some of the roles will be reusable. Typically with the Ansible operator, you're doing everything with the K8s module, whether it's K8s or OpenShift. That was introduced. It was rewritten in 2.6. It's very easy to use if you're using YAML files right now for your, for pretty much anything you do with K8s or OpenShift, you can copy and paste that YAML from those files into the parameters that you send via the Ansible module.
So the other thing that I would add is that I think on March 6th, I've tapped Michael Rivnak and Carol Chen, who's on the call, and Daniel Messier, who's not, to do a briefing on operators for Ansible people. So we'll be talking more then about the APB operator migration story and how all that works. So mark your calendars, and I'll send out an announcement about that too. So that's March 6th. I think it's a Wednesday at 9 a.m. So that'll be, I think, helpful to onboard some of the other Ansible folks who are doing amazing work.
Cool. Yeah, and the one thing I forget about that to mention is, for those who may not be familiar with the Ansible operator, one of the things that really makes it super easy to do is when you're doing anything on K8s, you always have external resources you have to deal with. You deploy your application on your cluster, but then you have to go out and update your DNS entries. Well, with Ansible, it's really kind of trivial to have the operator go out and hit, Route 53 or whatever cloud DNS service you might be using as part of the operator managing the lifecycle of your app. You don't have to write all of that code. You just use the modules that Ansible already comes with to do that external resources. My other kind of standard example for something like this is, say you want to do a database backup to S3. You're running your own cluster. You could be running your own cluster anywhere, but you want to do your backup somewhere offsite, doing it into S3 so that you have a nice offsite backup of it. Again, with Ansible, using the S3 module to do it, it's, takes you no time to write a playbook to do that.
Cool. Any other thoughts, questions people want to add here around the Ansible topic? I will definitely send out the note on the operators for Ansible people talk, and next week there'll be a few others. Some more coming in the chat right now. I'm still okay here, Carol. I still have audio. Perhaps if you're trying to speak, maybe, Carol, you are muted. Carol, try saying something. You're self-muted. All right. Anyways, so I have a couple other folks that have willing to share their lessons learned, and the first one is Leonardo Rossetti, who's been working on building an operator SDK for OpenShift utilities and a few other things. So if you'd like to share your screen, I'll stop sharing. And Leonardo, I think I have you off mute now. Please.
Can you hear me okay?
I can hear you okay, but I can't see your screen yet. So if you want to share anything, please do so. There you go. Good to see you.
Okay, cool.
So first, tell us who you are.
Sure. So my name is Leonardo, also known as Leo. I work on Red Hat as well, but I work in a meeting with whole integrated. We basically just try to bundle things together in OpenShift. So our main line of work is around automation, and we use operators a lot. But we did have a problem where we needed to reuse OpenShift templates in an operator to deploy stuff whatever they do. And
Leo, if you could speak up a little bit louder, that would be helpful. You're very soft.
Can you hear me now?
Yes, I can. That's better. Thanks.
And so as I was saying, me and my team, we do use operators a lot, but at the same time we have to reuse OpenShift templates from other projects. So because of that, we end up creating this tiny operator SDK OpenShift utils, which basically has a bunch of has a bunch of libraries that helps you process OpenShift template and make it and turn it turn off and expose chose runtime objects in your operator, so you can create chose as usual, and then you can do whatever you want in your operator. So I actually created a tiny operator here, which is called OpenShift template operator. I'll just demo how it quickly works. Then I will work. I'll gotta show how the library is doing behind the scenes. So here I'll just first deploy the operator itself. And so while the operator is being deployed, I'll show you what the CR is like for this particular operator. So basically here I have a local, the local is like the local path of the OpenShift template for this particular operator. It's just your usual OpenShift template, and then you have a bunch of parameters. Those parameters, they are it's just a map that a map that contains your template parameters to be processed by the operator once you create the actual CR. So, okay, since the operator is running, I'm just going to deploy this particular, create this custom resource. As soon as the custom resource is created, it creates, it just process a template, which basically contains the deployment config object and service and the route. So what happens behind the scenes? So basically, scroll a little bit. So basically, in this bootstrap, I just load the template and I initialize this template with which goes to the library. So it basically loads the template object as a raw Kubernetes object into struct, and after that, so here it configures the REST. It creates a REST config object to be embedded into this struct by itself as well. So so here we are just configuring and like the REST configuration, so it can like process the template object in OpenShift. So afterwards, it contains this install phase. That's where I get the parameters from the custom resource. I map them into a new map, and then I invoke this process method here. So it basically fills the local parameters. Then I just get an unstructured runtime object, and then I send this object to the process templates resource or method field, and then it returns me the process template. The OpenShift API returns me the process template, which then I basically loaded as a Kubernetes resource data, Kubernetes resource, so I can read the runtime objects that has been processed. So once I read those objects, they get stored. They get stored into the struct itself to be later retrieved by the operator. With basically, we have this get object method, which basically returns a bunch of runtime it returns an array or a list of runtime objects. You can apply the filter here. The filter is basically it's basically a function. In this particular case, it doesn't do anything. I have this default no filter function, but if you do return an error while using this callback function, the particular runtime object in the loop won't be added into the list in case you need to filter or something. And then here I just set the correct namespace for the instructor for the runtime object. I set their owner as well, so the CR can own all those objects. And then I just use the operators, the K runtime client, to create all those objects in OpenShift. And here just check if the deployment config for a valid deployment config state, so I can know that the deployment has been completed. It's a bit easy here because just have one deployment, so it's not as dynamic as it should be. If it was like a real case operator. And for library wise, that's the main functionality, the library. And there is also one last thing. So we also just expose the OpenShift schemes, so you can easily add support shows in your operator. It's just an array that contains all the entity schemes and methods from shows OpenShift native types. So we don't need to do. So the library was mainly created so the developer wouldn't have to worry that much about OpenShift details. We just have to have those basic steps to support OpenShift template processing on OpenShift types. And the last thing that I would mention when using OpenShift types in operators, okay, is that if you're using template, you need to use the full API version version string, not just like v1. Otherwise, the server won't be able to find the correct path for the group version, and the processing of the template will fail. Last but not least, if we go here, the resource called OKD template. You check here the finalizer, everything else, you have all these tabs and so on. So you just since the CRs owns all the runtime objects, they all get deleted, including services and routes. It's something that you need to delete manually before just process the template by yourself. And that'll be mostly it.
So Leo, was there any questions you had for some of the, or any help that you needed on this operator?
Not for what do you mean? Like if there's like something that
is this something that people other than your group would use? Is it something that you want other people to take a look at and contribute to?
Yeah. So basically, so here we were all processing the templates ourselves in each operator. That led up to kind of duplicated code everywhere. So which is why we created this library. I saw one or two messages into the operators decay Google group where people were trying to do the same. So that's basically why inspired us to create this library. And of course, we'd love people would find it useful and use it for themselves or even contribute to it. Contributions and users are always welcome.
Are you planning on putting it into the community operator repo by any chance?
Yep.
Okay, perfect. That's down the right path then, I think. So if anyone has any questions or feedback for Leo, you can reach out and throw in maybe an issue on his repo, or reach him on the mailing list. And we have, I'm going to take over the screen here for a minute, and we pop back into HackMD. And in the chat, Simon Kroom, I think that's how you might say it, from StorageOS was talking about they're coming out with one too, so we'll make him probably one of the next upcoming ones, talk about any lessons that he learned. Right now, Andrew Block and Matt Bagnara had yet another operator that I had been interested in for a while from community of practice inside of Red Hat. So I'm going to let Andrew explain what that is and who he and Matt are and what they've been doing. If you want to share your screen and take it away, Andrew, that would be great.
Absolutely. Thanks, Diane. Hi, everyone. Just going to go ahead and share our screen. Can everybody see?
Yep.
Cool. All right, so we're going to spend a few moments talking about the image signing and image scanning service, which itself is an operator. And we can kind of talk about how this project kind of unfolded over the course of the last year or so. First of all, my name is Andrew Block. I'm a senior principal consultant at Red Hat. I'm also the co-manager of the Container and PaaS Community of Practice within Red Hat. The Community of Practice program within Red Hat is a way for those who are interested in a particular area or field of interest to get together, talk about it, develop new solutions, but then most importantly, go out and share their learnings with the community, not only within Red Hat, but also in the open source community, very much like we're doing today. And
my name is Matt Bagnara. I am a senior consultant with Red Hat, and I've mostly being customer facing, we were kind of struck with some of the issues that these customers are experiencing with image scanning and signing. We'll kind of go into that in detail, but I was brought in I wanted to contribute to the community of practice in that way.
So I first want to talk about some of the background of the image signing, image scanning problem space that we were trying to solve here. First of all, we wanted to leverage a lot of the existing OpenShift ecosystem. Obviously, there's a number of third-party vendors that have image signing and image scanning solutions, but we wanted to look first to leverage the native tooling within OpenShift. And the most important thing we need to think about is, especially around the terms of security, how do we guarantee that our images are safe for use, especially the ones that our developers who are developing on OpenShift are building? How do we guarantee that they're not including either some invalid or notorious upstream images, or they're putting some dangerous libraries into their applications? The goal here is obviously to increase security within the platform and in applications, and also to mitigate vulnerability. As I mentioned previously, we need to go ahead and utilize OpenShift's native ecosystems of tools, but then this solution needs to be highly integrated into continuous integration and continuous delivery pipelines that a lot of our customers work with. Very much like Matt mentioned, I work very much with different customers of all shapes and sizes, going as small as, somewhat startups to upwards of top Fortune 1, Fortune 2 companies. So we need to think about a wide range of customer use cases. So this project has evolved quite a bit over time. It first started out as what we call the image signing and image scanning project that was very much Python based. We were leveraging a tool that was developed by the Red Hat Community of Practice that basically watched for events from the OpenShift Events API. This is way before the days of the operator, lifecycle manager, operators in general, even before custom resource definitions. It reacted on changes from image and image stream events and the OpenShift API. and did leverage a number of OpenShift native tools that was leveraged by the platform, everything from OpenShift, OpenSCAP scanning, and the atomic scanning tools as well. Unfortunately, it did have a bit of a frail architecture, as certain events could be missed or duplicated. So we had to put some additional logic into our application, and also come with the assumption that we could end up having duplicated events, and functionality honestly really wasn't that great. So then custom resource definitions helped us get a little bit further down the road, where we were able to get away from that Python-based library and eventing model, and to leverage custom resource definitions and more of a native feel to how we were interacting with OpenShift. We were no longer going after the events API and utilizing just straight events and triggers from that. We went ahead and started leveraging more of a native solution, where we were bringing in custom informers, shared informers, and going and taking a lot of the learnings that the upstream Kubernetes community was utilizing and using their libraries for interacting with the OpenShift API. However, there was a lot of time spent not only learning about how shared informers and the Golang libraries work, but also how do we generate the libraries for modeling our custom resource definitions. I personally probably wasted 2 or 3 weeks just learning that ecosystem. So that, honestly, it was two things. It was a challenge, a pain, but also a learning experience. So we were able to create a brand new repository built upon the solution, and while it worked, it was great. It still required a number of custom logic that I built, and I myself and the team built, to talk to the OpenShift API and to monitor the different resources. And then really what changed the game for us was the unveiling of the operator framework last May, where we were able to now basically scrap a lot of the custom work that we had to do to interact with the OpenShift API, but also how we were modeling and creating our custom resources, the libraries that modeled those, and basically just standardize on that operator framework logic, which basically gave us the boilerplate that we needed. So I basically went ahead and eliminated about 90% of our code base, went ahead, remodeled on the OpenShift, on the operator framework, and was able to instead worry about, did I put the right logic in for interacting with the OpenShift API, and instead focus on the business problem. Focus in how I'm going to go ahead and implement image signing and image scanning, instead of how am I going to talk to OpenShift API? How am I going to know about when changes occur? The framework provided that for me. All I needed to do is change my logic slightly to implement what the framework needed. And it also gave our team the ability to then be able to interact with the burgeoning community that the operator framework had. We were able to talk with others that were having some other challenges for interacting with the OpenShift API, learning some best practices, lessons learned, and that's really what we started to do, is starting interacting with the community and able to harden the support and stability of our project. So what exactly does the architecture of the image signing and image scanning service look like? So for those of you familiar with OpenShift, you're familiar with the fact that you can perform various build types on the platform. You can create images and then push those to OpenShift's registry, and then make use of image streams. So the first step is for a user to start a build and to have the platform build that image and push it to OpenShift's integrated registry. Once it's available in the registry as an image stream, you can create a custom resource called an image signing request. Our operator is going ahead and monitoring the creation of that custom resource. When it denotes a new resource is available and created on the platform, it goes in, validates that it is a valid image stream, it exists in the registry, and then it goes ahead and creates a signing pod, and then that signing pod will go in and sign the image. It has a GPG key, because that's what the Atomic Tools leverages by default, that is automatically configured inside the cluster as a default key that can be leveraged. However, in addition, let's say a development team has their own key they want to use for their image, they can provide that as a secret within their project, and the signing pod and controller will go ahead and configure that to be used by the signing process. And then finally, once the signing process completes, you can go in and then push that updated image to the OpenShift registry for deployment time. We also provide, in addition to signing, we also use OpenSCAP scanning as well. So instead of having an image signing request, you have an image scanning request. And in a very similar process, it goes in and scans the image. Now, Matt's going to talk a little bit about how this whole ecosystem was used in a customer use case.
All right, yeah. So I typically work in an environment where security is a big concern. Just the ability to inspect and ensure that what's running is what is actually running, and to go inside and be able to inspect these container images. We don't want developers pulling in random things, writing code that introduces vulnerabilities into the baseline, and using containers in this environment is kind of new to the customer anyways. So we really want to give the security folks in this organization a warm feeling about what they're using. So what we're able to utilize in this case is some of the security scanning for runtime images. Like I said, in a production environment, you have all these containers running. We want the developers to be able to self-provision their own scanning requests for these images that they're building. It utilizes atomic scan under the scenes, but however, that's also pluggable. You can substitute different scanning mechanisms, and we know there's a number of tools out there, but this is primarily focusing on the OpenShift suite of tools available. Security folks also want to ensure container image provenance. So having this chain of custody through the form of digital signatures is key. So something that gets deployed into production, we want to be able to trace that signature back to when it was built, match those up, and say, yes, this is the same artifact that was built in the dev environment, then that is being deployed in production. And then finally, for production deployment, security organizations can enforce these image scans. So they can initiate an image scan, and upon successful completion, they can sign that image. So back to the previous example, developer creates an image, it gets scanned in the development pipeline. That successful scan triggers a sign mechanism or a sign object to be created using the operator CRD. This ensures that only approved images will run in the production environments. So only trusted images actually make it through this pipeline.
So for those of you who are interested in learning more about the image signing, image scanning service, we have a number of links here. I'm sure Diane's going to go ahead and share this deck out afterwards, so we'll be able to share that out with the entire community. We have our repository resources. We also have a demo that demonstrates this entire process for image signing and image scanning. We also have some links to some of the tools that are being leveraged during our actual operator logic. Are there any questions? And first and foremost, thank you everyone for the time to be able to demonstrate and talk about some of the work that we've done on the image signing and image scanning service. Thank you.
So I have a quick question for you about ongoing support for this. I know this is in your repo right now, but is there any thought about maybe moving this over into OpenSCAP and asking the community there to work with this and maintain it? And what are your plans for maybe moving this into the community operators?
So definitely looking towards putting it into the community operators. Haven't thought a lot about bringing it into the OpenSCAP team yet. You obviously bring a good point there. This has been kind of on the back burner for me personally for some time, but especially as OpenShift is going to be going to a new version in the next few months. This is certainly an area that we want to make sure that we make as compatible as possible for the new ecosystem if there is any changes. Well, fortunately, there shouldn't be, but that is a good opportunity to be able to re-engage and look at the architecture moving forward.
and also for customers who are looking to utilize this, it would be a good opportunity because I know in my environment, we have a lot of issues with identity and whether or not these community products or projects, if Red Hat's willing or companies are willing to absorb any legal risk associated with using that in the production environments.
So there's a whole, and maybe Rob can speak to this a little bit. There's a whole partner program for certifying your operators and all of that. But since this lives and breathes inside of a community of practice group inside of Red Hat, that's the one thing that I would say is that for projects of this nature, which are awesome, and you guys are totally prepared with the slides and everything, and I totally appreciate that. But I sort of I have a concern about ongoing support, like as we do release 4.0 and other things like that, like how what the roadmap is there, and if there is adoption at customer sites and along that lines, we can get maybe the customers involved. And it would seem, and maybe it's not appropriate, but I kind of think that the OpenSCAP repo might be a good place for it to live and breathe. If they'd be willing for you to plop it in there and work on it as a community there.
Yeah, we can definitely go ahead and have some of those conversations. I know one area that I know we're going to have to reinvestigate as we go into the 4.0 is the utilization of Docker. I know there's a heavy dependence on Docker right now. So that's one area of improvement and evolution that we're going to have into the 4.0 space.
Yeah, I think that's probably a topic for another day, is moving from your Docker dependencies over to using Podman and Builder and all of the other stuff that comes with Cryo.
Exactly.
Be a good one. Rob, are there any words of wisdom that you want to add in here? We're at the end of all of the presentations that I had built up and collected for today. Go back to sharing my screen.
Sure. Yeah, I just want to say that it's really awesome seeing what people are building. Thank you for sharing some of your operators today. In the chat, we were talking about the Storage OS cluster operator, and so excited to see things like that coming to help folks better take advantage of some of the Kubernetes features around storage, persistent volumes, logging, all that good stuff. There's a really great set of operators underway to help with all that. So we'd love to get those added to our community repo so that everybody can benefit from them and try them out on their cluster.
Cool. And I don't know if Simon is still on, but maybe our next meeting is going to be again on the third Friday of the month, which happens to end up March 15th. So if you're interested in sharing your lessons learned or walking through what your operator does and how to use it, we'd love to have you come and do that. And if you, while you're out there in the Google group or whatever, if you come across one of the operators someone's talking about that you want to hear about, let us know, and I will try and coerce them into sharing their stories and telling you more about it. And again, we had it's in the calendar, but I'll send an announcement to the Google group and post it on the Kubernetes operators about operators for Ansible people, which will be March 6th. So that's the other thing. And operators for Ansible people.
Hi, Diane, it's Simon. Yeah, I should be able to present the Storage OS operator if people would be interested.
Oh, definitely.
Yeah. Let's see how far we get, and then I'll confirm.
And it doesn't have, and I keep trying to tell people, it doesn't have to be perfect. It can be alpha. And really, like you can see, there's a wide variety of conversations in the SIG. So don't worry if it's not production ready. What we're really trying to see is what we can learn from each other here. So And if you need advice or help, just one, jump on the Google group. I think the link is down below on the page here. I hope. No, probably I didn't. But I'll grab that now. If you haven't joined the Google group, it's right
A quick
here.
question: is there a meeting invite for the meeting, just so I don't miss it, or is it?
Yeah, I will send you a specific one. But if you go to the over here and throw this in, join that, and I post the meetings on events. Here on the Commons, which is the OpenShift Commons community calendar. So it should be, you're seeing my screen. But all of the events that are in all of the other SIGs as well, whether it's the machine learning, telco, and others, all here. And there's an RSS feed that you can subscribe to at somewhere at the bottom. So if you're looking to keep track of everything that Diane is trying to keep track of, it's here. The other thing that I was going to mention today is on March 11th in Santa Clara, there will be a Kubernetes hands-on workshop. And let me grab the link for that. And there's also going to be some really interesting, and I don't know where you're based, Simon, but the trainings haven't been listed here, but there's going to be a whole lot of talk about operators in the morning at this OpenShift Commons gathering. And I'm also going to run a parallel track, and in the afternoon from 1 to 4, Michael Rivnak and Matt Dorn are going to repeat the hands-on community Kubernetes Open Operator Framework workshop.
I went to that in London, and it was extremely useful, so I highly recommend it.
Yeah. Oh, that's where I recognize that accent from.
I could probably present the ML flow operator next meeting.
Okay, and that's Zach Hassan. Yeah, I recognize that voice too. Hello.
Okay.
And yeah, that would be great. So there's lots going on. There will also be a hands-on workshop at Red Hat Summit in parallel with the OpenShift Commons gathering there in May as well. And I just keep trying to, wherever I do anything, book an extra room so that we can also do the operator framework workshop too. So look for those announcements, and I'll send those out onto the mailing list. But if you haven't signed up, anyone who's on this call and has not signed up for the Google group, please do so. It's really where all of the announcements go out. So there you go. Anything else anyone wants to add? Because I'm 2 minutes away from having to go to another call, so I'm going to let you ask any questions in the Google group. Or on the Slack channel in Kubernetes operators for real technical conversations too. So please reach out, and thank you all for joining us today. Much appreciated.
Thanks, everyone.
Especially the presenters.
Thanks, Diane.
Thank you.
All right, take care all.